Hello students, in today's session of NCERT Chapter, Mechanical Properties of Fluids, very basics on the topic of surface tension will be cleared through illustrations. In earlier session, we have gone through one session through pressure, one session through laws of flotation, one session through Bernoulli equation, and another session on viscosity, which you can review on YouTube channel sethiswiftlearn. In today's session, we are going to discuss what is surface energy, big rod drives from below, and capillary rise, and other number of topics are going to delay. It is requested, please go through the complete session video. Now let's start with the concept and questions. Before I start with the questions, let's discuss certain concepts regarding surface tension and surface energy. What is surface tension? Molecules of liquid reach to its surface after struggling with net inward force acting on them from other liquid molecules. So we can say that surface molecules have some extra energy compared to the inner molecules, and every molecule has a tendency to keep its energy minimum, right? So liquid has a tendency to keep its energy minimum by putting least number of molecules on the surface or by making its surface area minimum. This property of liquid is called surface tension. Mathematically, surface tension T equal to F by L. ml T minus 2 upon L, that is M T minus 2. What is surface energy? When the surface area of liquid is increased, the molecules from the interior rise to the surface. This requires work against force of attraction of molecules just below the surface. This work is stored in the form of potential energy. This additional energy per unit surface area due to their position is called surface energy. Relation between surface energy and if there is a relation between surface energy per unit surface area is surface tension. So energy per unit energy, surface tension per unit area. That is energy per unit area, surface area is called surface energy. This is the relation. Excess pressure across a spherical surface. Surface tension causes a pressure difference inside and outside towards concave side. P1, P2, P1 is greater than P2. Means pressure towards concave side is always greater than towards concave side. Is greater than convex side, right? Excess pressure means Pi minus P naught, that is delta P equal to 2T by R, and in this case 4T by R. So अगर two surfaces होते हैं इसमें single रखते हैं, ठीक है? Now next regarding angle of contact. What is the angle of contact? What is angle of contact? The angle which the tangent to the liquid surface at the point of contact makes with the solid surface inside the liquid is called angle of contact. This is the angle of contact. This is angle of contact. Those liquids which wet the walls of the container, say in case of water and glass, have menses concave upwards and their value of angle of contact is less than 90 degrees. If angle of contact is acute, wetting will be there. If angle of contact is greater than 90 degrees, that is obtuse, wetting will not be there. Right? The angle of contact of mercury with glass is about 140 degrees. Angle of contact increases with decrease in temperature. What about impact of impurity? Angle of contact increases with addition of soluble impurities and decreases with insoluble impurities. Right? These are the two cases given to you. Capillarity. Surface tension causes elevation depression of the liquid in liquid tube. This effect is called capillarity. Capillary rise is equal to H equal to 2t cos theta upon r rho. The acceleration due to gravity, density of the liquid, radius of capillary pipe, surface tension, theta angle of contact. Right? These are the for insufficient length. Right? Now let's start with the question. Question is, if W1 is a work to be done to form a bubble of volume V from a given solution, the work required to be done to form a bubble of 2V is, four options are given to you, one of the options is correct. Concept applicable in a solution. We have to given W, work done and volume. Means to conclude the answer, we have to develop relation between W and V. Right? How to develop? You know, work done equal to surface tension into area. Surface tension T into 4 pi r square. This is work done. Right? Now, we have to eliminate R in terms of V as volume of bubble. Volume of bubble will be spherical. V will be equal to 4 by 3 pi r cube. Therefore, R comes out to be 3 upon 4 pi 3 upon 4 pi 3 upon R. 3 upon 4 pi 1 by 3. This comes out to be R. Now substituting in this one. So W comes out T into 4 pi into R. R is 3V upon 4 pi R square, that is 2 by 3. R 2 by 3. Therefore, W proportional to V की power 2 by 3. W proportional to V की power 2 by 3. Remaining parameters constant. Remaining parameters being constant. So W1 over W2 equal to V1 over V2 2 by 3. Then W upon W2 to be find out equal to V upon 2V power 2 by 3. That is 1 over 2 की power 2 by 3. W2 equal to 2 की power 2 by 3 W. एक तो आंसर हुआ. आंसर देखते हैं इन टर्म्स ऑफ 4. तो इसको लिख सकते हैं 2 की पावर 2 तो 4 की पावर 1 by 3 W. This is the answer. Let us see which is the correct answer. B is the correct option. B option is correct. Right? Next question. Question is, two separate liquid bubbles, radii 0.04 meter and 0.002 meter, form of the same liquid, surface tension 0.07 Newton per meter. come together to form a double bubble. Find the radii and sense of curvature of the internal field. Right? In this case, two radius are given to. One is R1, 0.004 meter. Another is R2, 0.002 meter. R2 is greater than R in this case. R2 is greater than R1. Surface tension is given to 0.07 Newton per मीटर. इसका डायरेक्ट फॉर्मूला भी है, वो बताएंगे बाद में. पहले इसको बेसिक कॉन्सेप्ट सब क्लियर कर लें. प्रेशर towards concave side is always greater than the convex side. Using this concept, these are two. This is R2, this is R1. So P1 will be equal to, this is liquid bubble set, 40 by R1 plus P0. P0 is atmospheric pressure. Similarly, P2 will be up to 40 by R2 plus P0. Right? Now, R2 is less smaller. So P2 minus P1 will be equal to 40 1 over R2 minus 1 over R1 plus P0 minus P0. This is cancelled out. This is excess pressure. Delta P equal to 4 pi 1 over R1 minus 1 over R2, 40. So this is equal to 40 by R equal to 40, 1 over R1 minus 1 over R2, 40. This is goes 1 over R equal to 1 over R1 minus 1 over R2. This is the formula. We can use it directly. On substituting values we get R comes out to be 0.004 इसको ले लीजिए 1 upon R1, 1 upon R2 आएगा, R2 upon R1, R2 upon R1, R2 upon R1, R2 upon R1. So 1 upon R2 is 0.02. 0.02 minus 0.04. Also होगा 0.00. इसको सॉल्व करके simplify and get the answer. Right? The direct formula is this. If two drops combine, then what is the radius of the interface and sense of curvature of the interface? Sense of curvature of interface will be concave towards smaller radius. Right? This is all about. This is a smaller, so this will be the shape of the interface. Right? Next question. Before start of the next question, I would like to say that these concept clearing videos for the purpose of 11th standard, 12th standard, state boards, CBSE board, JEE Main, JEE Advanced, NEET, CUET, and other entrance examination. These concept clearing videos are very helpful and useful, which you can review on YouTube channel sethiswiftlearn. In addition to this, I would like to say that these papers, complete video of discussions are available on sethiswiftlearn YouTube channel, which you can review on sethiswiftlearn. In addition to this, further, these papers, detailed solution with additional information available on website sethiswiftlearn.com. You can visit the site and have the solution. इसी के साथ साथ मैं रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आपने YouTube चैनल sethiswiftlearn सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद योर colleagues and friends. Now let's start with the question. Question is, calculate the energy released when 1000 small water drops, each of radius 10 to the minus 7, collapse to form one large drop. Surface tension of water is 7 into 10 to the minus 2 Newton per meter square. Concept applicability and solution. Here, small drops combine to form big drop. इसकी each radius r है, इसकी capital radius r है. According to question, 1000 into 4 by 3 pi r cube equal to 4 by 3 pi r cube. This is goes, r comes out to be 10 hours. R comes out to be 10 hours. Now, change in area. Final minus initial. Final 4 pi r square minus 1000 into 4 pi r square. That comes out to be 4 pi r square, 10 r already. 4 pi into 100 r square minus 1000, 4 pi r square. This comes out to be 96, 1000, 4 pi r square. This comes out to be r square. तो 4 pi common लिया, r square common लिया, 1000 minus, that is minus 900 into 4 pi into r square. This comes from decrease in area. That is, there is decrease in area. Therefore, energy released. The energy release will be equal to surface tension into change in area. That is, surface tension is given to 7 into 10 to the minus 7 into 10 to the minus 2, 7 into 10 to the minus 2 into 900 into 4 pi into r square, 10 to the minus 7 meter, 10 to the minus whole square. इसको simplify करके this comes out to be 7.9 into 10 to the minus 12 joules. This is the answer. Right? In this case, same concept was there. First of all, find the radius of the bigger. Means find the relation between the smaller radius and the larger radius. Right? Next question. Question is, if a 5 centimeter long capillary with tube with 0.1 mm diameter, open at both ends, is slightly dipped in water, having surface tension this 75 dynes per centimeter. State whether water will rise up to halfway, up to top, or overflow. 3 parts are there. Concept, applicability and solution. Capillary rise. Is equal to twice T cos theta upon R rho G. R rho G. What is there? R is 0.1 divided by 2 into 10 to the power minus 1 centimeter. We will follow the CJ system. Density of water is 1 gram per centimeter cube. G 980 centimeter per second square. Theta angle of contact for pure water is 0 degree. The cos 0 will be 1. Surface tension is given to 75 dynes per centimeter. If we calculate it, we get it H equal to 30.5 centimeter. Rise is 30.5 centimeter. What will rise in the halfway to capillary? No. Length of capillary is given 5 centimeter. Rise is 30%. So will rise in the halfway, it will rise full. What will rise up to the upper end of the capillary? Yes. What will flow outflow of the upper end? No. No. Will not overflow, but will adjust according to formula H1 R1 equal to H2 R2. 30.5 into 30.5 into R1. You find out कर लेना. Length रखे initially 5 centimeter. 5 into 0.1 divided by 2. 10 to the minus 1. On simplification, we get R1 comes out to 0.0306 centimeter. This is the answer. Means water will not flow out of the upper end of the capillary. It will adjust its radius according to the formula H1 R1 equal to H2 R2. This is the new. This is the given. Right? Now, I would like to request, if you are new to my YouTube channel, sethiswiftlearn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.